Yeah, in the last session, we have just discussed about the linear regression. Good morning, all of you. In the last session, we have discussed about the linear regression. So in the linear regression, we try to understand the set of predictors and the response variable out of which that we try to understand sum of least squares, which comes out with the best R square model in the Python. Okay. Today, we are going to look after the multiple linear regression model. Okay. So what is the general equation for the simple linear regression? All of you, what is the equation for the linear regression model? Simple linear regression model. Anyone? Narayana? Anusha? Ashok? Sunil? No, generally this follows y is equal to beta naught plus beta 1x. This is the formula for the simple linear regression, okay, which is mx plus c model. Okay, y minus y hat and all stuff, that we will deal with the sum of squares. We are going to see there, that is called a residual. Actually, the sum of residuals together, we can calculate the sum of squared errors. Okay, so multiple linear regression model deals with y is equal to beta naught plus beta 1 x1 plus beta 2 x2 etc. plus beta n xn. So here this depends upon how many predictors that we are carrying here. Okay, how many predictors that we are carrying for the multiple linear regression. If we do have one response variable and 5 predictors, we will go ahead with the 5 values of beta 1 and beta 2, beta 3, beta 4 and beta 5. Okay, 5 beta coefficients and respectively the 5x values. Okay, and now coming to the one more stuff, which is a polynomial regression. Okay. This will deals with this is how it works actually. Take a look at this one. This is how it works. Beta naught plus beta 1 x plus beta 2 here. When we considering the polynomial regression, we will have something like a polynomial equation. Okay, hence this x value will become x1 power square, okay, plus beta 3 x beta 2 x2 power square. This is square. Sorry, this is x2. This is 3 that I can see. So we can understand the polynomial regression will show you a different types of equation. Why? Because it is going to be a curve literally. So it represents the equation of the curve. Okay. And even we are not required to give it as. So the model represents, you will have the different x values, x1, x2, x3, something like that. Okay. Beta 1 x1 plus beta 2 x2 square plus beta cube, beta 3 into x3 cube. Okay, so it goes on something like that, which will resembles a curvy nature of a line. Okay, so here now let us look after this particular multiple linear regression. No, this is just a square for x2, not for all. Let me just show you something like this. Okay, are you good now, Sunil? So here, now let us try to understand a program of this one. Let us go to the multiple linear regression. As usual, I have just imported the NumPy, Matplotlib, and the Pandas, all three together, and then data set equal to PD represents Pandas dot read underscore CSV. I have something called a data using 50 underscore startups dot CSV, which is located in the E drive, out of which where I thought of accessing to capital X and the small y. There are two different variables for me. Let me just show you how this variables looks like. So if you can take a look at this one, guys, you can see there is some sort of categorical data, right or wrong? Hmm? There is some sort of categorical data. Hmm? So now, and also let me just show you y values. So these are all the value of y values that we have. See what kind of information that we do have within this particular .csv file. Okay, we have different types. So let us take a look at this part even. If we just go ahead with my so no. So salary underscore data. No, I think this is not the salary underscore data. Let me just open 50 underscore startups. So guys, if you can take a look at this 50 underscore startups. You could see that the state represents the categorical data, right? You could see. Okay. Okay, fine. So what exactly that we are targeting in order to understand the target variable or the response variable? I'm much more interested in the profit. See, based upon the investment that I have made in wide variety startups, what is the best profit that I'm coming out with? Okay. If I am going to spend R&D for R&D and the administration and the marketing in the one particular state, this is the profit that I'm going to get. If I'm going to spend so and so in R&D and administration and the marketing in New York, so and so that I'm going to get as a profit. So something like this, if at all, if I just wanted to spend something on one particular kind of startup, so how would we get an understanding about how much profit that we are going to get? So here I just showed you the values that, see, I just need to use to pre-process the data. Why? Because we have some category variables, categorical data. So guys, in Python, we have something called a label encoder. Okay. We are equipped with something called a label encoder with which we can convert the categorical value into a numerical value. You can see that the third index, okay, in the indexing of the third column means like 0, 1, 2, 3, third one. Okay, I mean the fourth row, fourth column. The fourth column consists, in the capital X, so the fourth column consists the categorical data. In order to fix that categorical data, I have just imported the label encoder and the one hot encoder. The label encoder equal to the labels. I have just created a function of this one. My variable is something like label encoder x colon comma 3 equal to label encoder dot fit underscore transform is a method where I need to use to pass the data. Okay, where it will pass it. See, but just going through the label encoder will not fit my data. I mean, will not, it will just make some unusual sense of the data, how it is going to recognize about. That's why whenever you are using a label encoder, alternatively, you should have the, along with the label encoder, you need to have the one hot encoder. Okay. Remember that one. This is very important when you are working with the categorical data. Okay, for the regression problems. Understand? Why? Because if you don't use the one hot encoder, the system or the algorithm will think that even then as one of the values, and it will try to process it. Okay, it will try to understand that in a different way. So that's why you need, in order to make that one very much clarified, one hot encoder is equal to one hot encoder of, we need to pass those categorical features, okay, where we need to provide the index, proper index of that. Okay, and finally x is equal to one hot encoder dot fit underscore transform x to array. Okay, these are all categorical data now has now become, okay, into a numerical stuff of array. Okay, so and also we can avoid some of the dummy variables, okay, by giving some values associated, and you can see the resultant data. This is how it is looking like. Earlier the capital X is showing you the Florida and all cities, and can you see this kind of data right now? No, right or wrong? You are not able to see that data, okay, and you could see the different style of data. They are all completely different. Are you all with me, guys? Why? Because after the usage of the label encoder, the one hot encoder, okay, and also that we have tried to trap the dummy variables. Dummy variables, what do we mean by the dummy variables, guys? Basically the dummy variables are the one, particularly in the machine learning, whenever we talk about the dummy variables, they are the one which we need to fix within the data. Okay, so mostly in order to give the priority. Why? Because we need to, if we keep that dummy variables, what happens? We will get the wrong results. Okay, if we are going to have the dummy variables or dummy values in the data, okay, so we need to have, we need to avoid the dummy variable kind of stuff here. Why? Because generally in the statistical terms that we will call it as a indicator, okay, we can have the dummy variables, we can add the dummy variables. There is a one particular significance when to use and when not to use. Okay, generally it will take either 0 or 1 kind of stuff in order to make out some clearance from the categorical effect of the data. It will be used as something as like a Boolean value, you can say, male or female, representing 0 or 1, which will indicate the gender absence or presence, so that you can replace it with the some sort of categorical effect, right? Okay, so the purpose of the dummy variables where is none other than artificially creating some variable which is representing on one particular categorical attribute. All of you understand this part? So we understood that something, whenever we have the categorical data in our data source, we need to understand accordingly with the proper, we need to transform that data in accordingly using label encoder and the one hot encoder. So now even that we have avoided the dummy variable kind of stuff, and now I am trying to process by splitting the data set into the training and the test set. And if you can take a look at this one from scikit-learn.cross-validation import, training test split. I'm going to split the data with a ratio of 0.2. Tested data represents the 0.8 training data. Okay, and now I'm going to make, so this is the regressor dot fit. We can always try to get the score again or to score here. One second, just give me a moment. Okay, so okay, let us use this one a little bit later. Now let us also understand the prediction. Why? Because we did not look after this part. So we have done the proper predictions also, but I did not. I can just even, execute this stuff. These are all the predictions for the proper test data. Okay, and also now what I can do, I can try get this. See, I did not use any sort of, the visualization for this part. You can try doing the visualization based upon comparing with the simple linear regression model that you have. And also, let me just try out this one. Okay, import linear regression. Now, what I'm going to do, I'm going to get this. So we have the R square, the model which is 0.93, almost 93.4 percentage is the model accuracy, which is quite good. Okay, and these are all the predictions that we do have for the proper test data where we do have, we can always even check like what exactly the test data that we do have based upon this. See, if you just wanted to check the test data, and you can always check it something like this using the x_test. See, this is the test data, but you can't understand directly. Why? Because it was encoded by the hot encoder, one hot encoder and the label encoder. So hence this is how it looks like. All of you, any questions so far? If you don't have any questions, we can just jump into the polynomial regression. I will share you all these three programs today so that you have to go through them and you have to execute. Any questions? Anusha, Ashok, Narayana, Ram Dinesh, Sridhar, Sunil, Suresh. Okay, fine. Then I will just get on to the polynomial regression, guys. So here I am just there at the polynomial regression. Okay, so I'm going to use the position underscore salaries as how we have did it for the simple linear regression model. The same data set I'm going to use in the polynomial regression. No. This is a little bit different actually. So the position underscore salaries depends upon uh, by the total number of years. I think it is the same thing that I have used even here. No, it is a salary data and this is a position underscore salaries is a little bit different. So, okay, position underscore salaries is somewhere here. Let us take a look at the data how exactly it is looking like. So based upon the level of or the position, okay, how much the salary it is representing for each and every person. Now let us try to understand how exactly this data to be built and or understand a particular polynomial regression onto this particular stuff. So as usual, NumPy and Matplotlib, the pandas would be important. Apart from that one, we will be setting up the x and y values. So let me just show you x and y values, which is going to be represented over here. So these are the y values, but anyhow, I just want to print the x values also. These are the x values. Okay. So here, um, it is taking only the levels and the see it is taking only the levels. Why? Because each and every level signify the proper position. Okay, and the salaries, respective salaries are there already. So I just want to show the linear regression model here, and there you go. I'm using the polynomial features, which is see earlier I have just simply performed the linear regression, okay, which is a general fit, which will not give you the right arrangement of the data based upon this. Okay, so here, this is how even the visualization of the linear regression looks like. You can take a look at this one. The plotted dots are little bit curvy, and whereas the straight line which is representing, which is a regression model, is slightly different. Okay, so hence let us not quite see why, because we cannot depend upon this kind of model. Okay, even if you just go ahead and check the accuracy is going to be a little bit different. So hence let us try to understand this one in a more different way. Hence we are going to import, instead of linear regression, we are going to import something called the polynomial features. So when do we prefer the polynomial? Whenever we see something which we cannot work out with the linear regression, and if you can take a look at the visualization of it, where the regression line is nowhere in fit with the curvy nature of all the plotted points. And finally, I'm going to execute this part, whatever the fix that I have just made using the polynomial features, but passing the x and y values together under the poly underscore reg, which is going to be my polynomial features with a degree 4. Why it was degree 4? I can make my several degrees so that I can make use of the existing variables to work around with the certain kind of data. Here, my position underscore salaries are just 1, 2, 3. It's all just 3 rows. And even if I'm going to make it perform only 2 predictors, it is not even the degree 2, right? Polynomial degree 2. You can even try for degrees equal to 2, degrees equal to 1 even. Okay. So I have just given the degrees equal to 4 and the polynomial regression fit for the x underscore poly, which has defined right now to fit and transform to that particular stuff. And now this is how that my visualization looks like. So you can see that this is how much fit it looks like. Okay. And and we can also visualize the high resolutions, and if you want to visualize this for high resolution, this is the one, and which is also smoothing the curve how exactly it is going through. Okay, and these are the predictions for if you just wanted to predict something for one particular value, you can try always predicting that part. Okay, this is a change in the predictions of using a linear regression method and the using the polynomial regression. See, for the same 6.5, the polynomial regression given you the salary of around 1,58,000. Okay, whereas the linear regression is depicting you 3,30,000. So there was a lot of difference actually. Understand all of you? See the background. In the background, finally, the only thing works is the formula. Okay, but the front end we need to understand what are the functions that we are trying to use over here. Okay, in the front end, that what are the functions that we are using here, we are clearly mentioning what are all the libraries that we need to import when we are using specifically certain kind of functions. In the linear, for the linear regression, we are using the linear regression function. For the polynomial features, we are using the polynomial features function. We should be very much sure that whenever we are using one particular algorithm, what are the functions that we are trying to use and how we are separating the data accordingly. Very simple. If we know that part, and rest of the things are going to be a cakewalk for us to depict the any sort of visualization and the calculating any sort of score, I mean an R square score, and at the same time the results of the prediction. Are you all good so far, guys? Yeah, thank you.